Hello friends. So in this video I will show you how you can solve a pulley problem very quickly. So let's say I have a pulley system here and the mass of this block is M1 and mass of this block is M2. And there is a rope and there is a pulley, and in this kind of problem we have to find two things. What is the tension in the rope? So first thing we generally need to find tension in the rope. So we need to find tension in the rope, and the second thing that we need to find is acceleration of each block. So what is the acceleration? So generally we need to find these two things. And if you remember, in the traditional method what we do is we write for each block we write free body diagram and then we solve Newton's second law. But in this video I will show you quick method. In this method what we do is we consider a axis that is running like this. So this is a axis. So this is my x-axis. So x-axis is not a straight, it's a curved kind of thing. This is a axis. It's better to say some different kinds of axis. Let's call this as a zeta axis. So what we will do is we will consider forces along the zeta axis. So what are the forces that is acting? So on this case the force acting is M2Z. And on this block force acting is M1Z. We don't have to consider the tension forces because in this axis tension forces are internal forces. So what we are saying is tension in the rope. So you have some tension in the rope. So this rope will have some tension, but these tensions are internal. That's why we are not considering. So we are only considering the external forces, that is M1Z, and another external force that is M2Z. And this mass is moving in the downward direction. So let's say this system is going in the downward direction with acceleration A. So now we can write equation of motion, that is Newton's second law, that is force is equals to mass times acceleration. But now this we will write along the zeta axis. Not x-axis, not y-axis, my zeta axis. So for this zeta axis, M2Z is positive and M1Z is negative because this is acting in this direction. My zeta axis is running like this. So this is running like this. So this is in the negative direction. So minus M1Z is equals to mass into acceleration. What is the mass? Now you have to consider the total mass of this system. So total mass is M1 plus M2 times acceleration. Because we are considering this as a system, M1, M2 as a system, and this rope is also a part of system. So internal forces like tension in the rope is internal force. That's why we have not considered. So what are the external forces? External forces is equals to M2Z minus M1Z. What is the mass of this system? That is M1 plus M2. And acceleration is A. So from here I can directly get A. A is nothing but M2 minus M1 times Z divided by M1 plus M2. Now once you know the acceleration, you can find the tension. So for mass M2, for example, if you consider mass M2, now you have to draw the free body diagram. So for M2 you consider what are the forces that is acting in the downward direction M2Z. Let us say on this tension is T, because this one and this one both will have same tension. Let's call this tension is T, this tension is T. So M2Z and tension in this block is going in the downward direction. So now I can write equation of motion for this block, that is M2Z minus tension is equals to mass into acceleration M2 times acceleration. Acceleration we have already calculated, that is M2 minus M1 divided by M1 plus M2 times Z. So now we can solve for tension. So m2z minus m2 minus m1 divided by m1 plus m2 times z, because this z is multiplied, and this will be equals to tension. So what I have done is I have taken tension this side and this term this side. So I can write tension is equals to m2 into m1 plus m2, and this is z is also here, and this is m2 times m2 minus m1 divided by m1 plus m2. So from here we can say t is equals to, if I take z common and m2 also common, so we can write m2z. So here I will have m1 plus m2 minus m2 plus m1 divided by m1 plus m2. So m2 gets cancelled out. You will have tension is equals to 2m1 plus m2 divided by m1 plus m2, and this multiplied by z. So this will be the corresponding tension in the rope. So now see, we have easily calculated tension and acceleration in the pulley mass system. This was a quick. If you wanted, you can also solve by writing equation of motion separately. That is alternative method. So let us say, in alternative method, what you will do is you will consider this mass m2, and on this block forces is tension. m2z is acting in the downward direction, and this block is going in the downward direction with acceleration a, and on this block this is m1, force is m1z, and this block is going up with acceleration a and tension is t. So now you can write equation of motion for each block. For this you can write, because this is going in the upward direction, we can write t minus m1g is equals to mass into acceleration, and for this block you can write this is going in the downward direction, so I am taking downward direction as positive. m2z minus t is equals to mass times acceleration. So we have two equations and two unknown. Now if you add these two equations, you will have t minus m1z is equals to m1a, and the second equation is m2z minus t is equals to m2a, and if you add these two equations, tensions gets cancelled out. So you will have m2 minus m1 times z is equals to m1 plus m2 times a. So from here you also get the same value. Acceleration is m2 minus m1 divided by m1 plus m2 times z. Basically, if you look closely, what is happening is, if you see this equation, these two equations, basically tensions get cancelled, and that was your zeta axis. So in zeta axis this tension got cancelled. So basically in that case you are directly writing this equation because you are not considering tension. But if you consider two objects or two blocks separately, free body diagram for two blocks, then in that case you have to write two separate equations, and then you can find the tension as well as acceleration. So I hope you enjoyed this video, and if you enjoy, please share with your friends, like this video and subscribe to my channel. Thank you so much.